Right, we're back with basically trying to learn go through the book Mathematics and Lean, and the goal is to prove the very first proposition. Well, I guess not really first. Let's see. I guess the rest are definitions, but we're trying to prove this statement, which is let K be an infinite field, let F be a polynomial in, and what do we say? This is called, where's that? It's the set of all polynomials over the field K of n variables. So we have a polynomial and K is infinite. So I don't even know how to say the first thing, let K be an infinite field. I know how to say K is a field, but I don't know how to specify that it's infinite. Okay, then the next thing is we want to prove this statement. Then F is equal to 0 if and only if and only if the function from kn to k is the 0 function. This is going to be a tough proof because it relies on induction. I don't remember how to do induction. I remember I did it in the natural number game, but I don't remember it. All right, anyways, so that's looking ahead. And I was trying to read document. All right, so anyways, we're going to go back and we're going to prove these three, which we were working on yesterday. And I got through mole right in kind of. We need to translate it to. So the first thing we want to do is we want to make this thing equal to 1. So we want to have h be a times a inverse wait, is that right? Yeah, times a inverse times a inverse is equal to 1. Okay, and so the reason why we're doing this is we're trying to prove that this is 1. And if it is 1, then we'll be able to replace the 1 in this goal Okay, so what is it? What we have to do is all we have is the associativity of mole. 1 times a is equal to a, and this one. So we can't simplify this expression yet. So what we have to do is rewrite mol assoc k all right, well, let's just see what happens if I do this. Oh yeah, this one doesn't get simplified either. All right, so we need to figure out how to... Okay, wait, what was before this? A times A inverse. So we want to... Oh wait, we need to do this too. Okay, there we go. Then mol left inverse. Then 1 mol. Okay, then mol left inverse. Okay, so now we just proved that this actually is equal to 1. And so now we want to do rewrite h. No, I think I need to apply h. I forget how... Oh, you know what it is? Probably. It's probably... Okay, but then what do we do? I gotta pee. Okay. Oh, you know what? I probably forgot to change the stream info. Whatever. Whatever. Who cares? Okay, so... What did that rewrite? I rewrote this side to be times. Oh, oh. Okay, then we can just write. Okay, cool. That's it. So what did we do? We rewrote the right-hand side and simplified it down to show that this term is really equivalent to that term. And then we're good because we already know that the original right-hand side was equal to 1. Okay, then mole 1 is easier if you have mole right inv. Okay, so what is the strat here? Okay, wait, why did that do that? It took a times 1 equal to a and replaced the 1 with this side. Right, okay. So then, now we can just do mol soak. Okay, then mol right inv. Then we're done, right? 1 times a equals a. Oh wait, we're trying to do the other one. This is, yeah, okay, wait, so we messed this up. So I don't need this. Oh wait, I can just do 1 times a equals a. Aren't we done? A times 1 equals a. I don't get why this proof is not done. A times 1 equals a. It's crazy because I already did this proof. All right, mol 1 Wait, I think I had it actually. We had this, this. Oh, wait. Oh, wait. Why am I tripping, bro? Okay, yeah. I don't know why I was tripping. Right, so I want to try it again. I want to try it with how do I do it? N3 right? No, you know what? This is the best one to do. Okay, so the steps are that it goes a times 1 equals a is the goal. Then you rewrite that to be a times a inverse times a. Then you rewrite that to be a times a inverse times a without the parentheses. Then you do mole right inv, which becomes 1 times a. And then this gets written as a. It's equal to a. Okay. So here are the steps. So it becomes a times 1 equals a. Then a times a inverse times a. Then, oh, I forgot this. Then it becomes a times a inverse times a. Then it becomes 1 times a. Now this one is, I didn't even try to do this one. In rev. This one is tricky, man. All right, I want a hint. One mole. Wow, look at all those rewrites. It's gonna be a tough one. Okay, then it's clear the next thing after one mole is gonna be the left inverse of 1. Oh, not of 1. I gotta put this there. There we go. Wait, what happened? Oh, yeah. Right. Okay. Oh, wait. Oh, yeah, that makes sense. Mollisok twice. So that groups the second two. Wait, how did that do it? Okay. What changed? Okay, then, oh, you want to eliminate those, I guess? Uh, that's it? Okay, that's it. But you know what? That's the annoying thing about lean actually is like you can do the manipulations and really not understand the proof. So what happened? We rewrite the right-hand side to have an extra. That's a really cool thing. So what is it? It goes A times B inverse is equal to B inverse times A inverse. A, B, and G. So then we rewrite that to be 1 times, I think at that stage the last is Yeah, in parentheses. Then we do mole left inverse with A times B as the A, which means that it goes A times B inverse times A times B inverse times A inverse. Okay, then rewriting 2 mole soaks, change it to be A times B inverse times A times B inverse A inverse. 1, 2, 3. Okay, then we change it to be A times B inverse times A inverse. Oh, we don't actually need these parentheses. We need these parentheses. Okay, then mole right in. So then we have A times 1 times A inverse. 1 mole becomes A times A inverse, which becomes 1 A times B inverse times 1. This is probably one of the best exercises. I really like this exercise because you really got to do the thing. Okay, so I just want to write it out. What is it? It's like that? What's the block comment? There's a block comment. Okay, so it goes A times B inverse is equal to 1. Sorry, no, not 1. What the hell am I talking about? B inverse times A inverse. So then blank is equal to 1 times this. Then you do blank is equal to A times B inverse times A times B times B times A. Then you get is equal to, and we'll do 2 steps here, I guess. I think you need this. Then it goes to, this. Here's our QED. Nice. Little fucking box. So even though you can sit through and walk through those steps, it still feels weird. The reason why it feels weird too is because even after going through all the steps and proving it, you don't really see why it is that it couldn't also be A inverse times B inverse. But somewhere in these steps, there's just no way to rearrange, and it's not clear that that's true, but there's no way to rearrange to make it to flip this guy over here so that it becomes or rather if you were to rewrite this modal F inverse to be B times A. Like if I change this, then you can do all this, but you can't flip anything around, so you're stuck and you can't simplify it. Keep that commented out. All right, let's see. That is such a good addition. 1.88, wow. To not have to restart the whole thing, it's great. Okay, so now we are on to section 2.3, I guess. Okay, rewriting is great for proving equations, but what about other sorts of theorems? How can we prove an inequality like the fact A times... Yeah, okay. We already read some of this yesterday. We've already seen that theorems can be applied to arguments and hypotheses, and that the apply and exact tactics can be used to solve goals. The apply tactic takes a proof of a general statement or implication and tries to match the conclusion with the current goal and leaves the hypothesis, if any, as new goals. I think that's why I was confused about yesterday. Let's see, I forget exactly which one it is. It was an apply here that was... I think it was this. Right, because this leaves the hypothesis as new goals. So that's really what's going on there. The apply tactic takes a proof of a general statement or implication and tries to match the conclusion with the current goal, then leaves the hypotheses, if any, as new goals. If the given proof matches the goal exactly, you can use the exact tactic instead of apply. In the first example, applying LE trans creates two goals. Right. And we use the dots to indicate where the proof of each begins. The dots are optional, but they serve to focus the goal within the block introduced by the dot. Only one goal is visible. Yeah, within the block introduced by the dot, only one goal is visible, and it must be completed before the end of the block. Here we end the first block by starting a new one with another dot. We could just as well have decreased the indentation in the fourth example, and in the last example, we avoid going into tactic mode entirely. Oh yeah, see, there's no by here and there's no by there. What is the docstring for by? That's what I want to know. By tac constructs a term of the expected type by running the tactics. Huh. God, I hate the naming of this. I don't understand. Because of the right associativity, these LT. Okay, wait. This one is called LT of LT of LE. Okay. These names are really confusing, but I guess the only one that actually makes sense for the namings of these is that the LE and LT are the first ones here. And the middle one here corresponds to the first. Okay, so it goes 3, 1, 2. So less than of less than of less than or equal to. I don't know how I'm going to remember that. That is totally weird to me. I know that I'm sure it makes sense, but for me, that doesn't make any sense. Okay, we got an exercise. Sorry. Okay, so wait. So we want to prove A is less than or equal to E. So wait, it's 3, 1, 2. So we want to rewrite LE of LT. Do we have that? I don't even think that's a thing. Hmm. Okay, wait. Let me read the thing again. Let's walk through those examples because we didn't even walk through those. All right, so we start here. And we have 2 sub-goals now. I don't like how it shows that one. We have A is less than or equal to B. B is less than C. So we should be able to A is less than or equal to B. B is less than C implies that A is less than C. So that is going to be LT of LE of LT. Okay, so apply LT of LE of LT H0 And that gives us, wait, fail to unify A less than C. I don't know why I'm not supposed to provide two things. I thought I'm supposed to provide this in H1. Fail to unify this with that. Okay, I think I get it because I think I get how apply is working here, but I'm not exactly clear how we keep going. So then let's just apply the next one, which is probably, so now we have B is less than E. So this one was, so now we have yeah, LT of LT of LE. And that changed the goal from B less than E to C is less than or equal to E. Yeah, I don't know what the hell the answer is. Oh, what? Oh, we gotta wait. Okay. Why am I tweaking over this proof? Okay. All right, let me just think about it. So we have 4 hypotheses and a goal. A is less than or equal to B, and B is less than C. So we can use this to construct a new hypothesis. What was it? /n? Who cares? Okay, so we can use H0 and H1 imply A is less than C. Okay, so let's just call that. Then if H prime and H2, which is A is less than C, and C is less than or equal to D, implies that A is, yeah. And then A is less than D, and D is less than E implies that, done. So, okay, so I want to do it a different way. I want to say have H prime type. Okay, cool. All right. I like that. Okay, nice. Yeah, no. What's wrong with that type mismatch? No. Wait, where are we here? We have A is less than C, A is less than D, and D is less than E. So we should be able to have H3 be A is less than by LE trans. Why does that not work? Oh, wait. And then I should just be able to do that. Okay, so that proof makes sense to me. Excuse me. Oh, fuck. That's not what I wanted to write. I want to copy over some of these. And then I wanted to copy over these two. Or actually, no, all 3 of these. These are all real good. Okay. That's all I wanted to do. Okay, but I want to do another one of these. where I see how they use apply. So instead of using have, we apply, which one is it? Apply LT of LE of LTH0. Okay, so in this case, we take the conclusion A less than C Now the solution did what? We had B is then apply LE trans. Less than or equal to trans? That's strange, right? Because it's probably LT trans. Then it's probably apply LT of LE of LTH2 and then exact H3. Is that what they did? No, see, they gave both of those. Okay. Sort of makes sense. What is like the English way to explain this? So we give it H0, which is A is less than B. And it tries to rewrite the goal, which is A is less than C, with B is less than C. So then, okay, so then that's how we get this. Then we have LE trans or LT trans. We provide it H1, which is B is less than C, and the goal is B is less than E. So that means that we're allowed to conclude, and in this case, A is actually B and B is C. So that's why we get C is less than E. And then here we provided both H2 and H3, which is why we have LE of LT of LE of LT. And so we rewrite. So what happens when we provide both of them? We're done. Because we can conclude the proof. Okay, I think I get it. That was kind of tough, actually. In addition to equations and inequalities in the context, Linarith will use additional inequalities that he passes arguments. In the next example, exp le exp mpr h prime is a proof of xb is less than or equal to xc. Notice that in lean we write fx to denote the application of f to the argument x, exactly the same way we write hx to denote the result of applying a factor theorem h to the argument x. Right, the like functional underpinnings of this is really interesting. Parentheses are only needed for compound arguments, as in f of x plus y. Without the parentheses, it would be evaluated as f of x plus y. Linarith. Okay, fine. Here's some more theorems in the library that can be used to establish inequalities on the real numbers. Oh yeah, just throw me a ton of theorems. Thank you, guys. Add le add. Oh yeah, that's useful. Quantified over all c. And then this is the same thing. Then add lt. Yeah. These ones are crazy. Add non-neg, that's a good one. Add pause, that's a good one. Add pause of non-neg. Add pause of I wonder if there's a add pause of non-neg of pause. Yeah. Cool. Very cool. I wonder what the proof of X pause is. Damn, it takes forever to load this file. Here we go, we're almost there. Huh. Okay. All right. Some of the theorems use a by implication. We will discuss this connective in greater detail in the next chapter. Such a theorem can be used with rewrite to rewrite a goal to an equivalent one. Oops. Yep, that makes sense. In this section, however, we will use the fact that if there's a hypothesis of A if and only if B is such an equivalence, then H.MP establishes the forward direction A implies B, and H.MPR establishes the reverse direction B implies A. Here, MP stands for modus ponens and modus ponens reverse. You can also use dot 1 and dot 2 equivalently. If you prefer, thus the following proof works. Okay, what is the proof? ALEB CLTD. Which one is this one? Add LT of LT of L. Dude, I mean, what the hell? Okay, so what does this give us? So the first goal okay, that makes sense. And then exp LT exp reverse direction in H1 is this. Okay, cool. Wait, so at this point we get, huh? Okay. Bye. Sorry. I wonder if I can type ring. Probably not because exp. I don't know. I don't know why. Oh yeah, this one's not that hard because yeah, it's got to be add le add left. I like these halves. Uh Wait, is that right? So then, uh, nice. I like that proof. I like have. Have is one of my. Have is a tactic that I can get behind. What is the actual answer? Okay, that's also good. Let's do that one. Okay, so. Alright, so that gets rid of the C. Okay, then we want to rewrite exp LEXP. And so that just figures out which way to. Yeah, I like that too. Okay, then apply the same thing. Add LE, add left, H0. Okay, cool. I like both of those. Frivolous. Down, 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 down. Um. Dun, 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 dun. You know what I'm feeling like, actually? I'm feeling like, what? Let's see. Wait, what the hell? I just want albums. Plastic Beach. This album is probably fucking good. Let me just listen to the hits for right now. Up on Melancholy Hill, there's a plastic tree. With me. All right, enough messing around. Okay, so we're just proving this. I probably can just type norm num here. Why is this not? Okay, if I were just to say, okay, so I think I want to do it by, oop, add pos. Wait, hold on. Okay, that is exactly what I wanted. Wait. Wait. Oh, here's what I want to do. Okay. I don't know why they even wanted us to write that thing. Oh, okay. All right. Makes sense because this thing also needs proof that inside the log is positive. So I could do that. Let's see what they have. Oh, there it is. Up on Melancholy Hill, there's a plastic. Okay, so after line 2, what do we have as the goal? Oh, that's concise. That's almost a little too smart for me. In some sense, I actually like the longer proofs because they're clearer. You know, they're not so whatever. See here, first we say add pause, and then we need two things. First, we need to prove that the first one's positive and the second one is positive. And actually, do we add non-neg is probably also a... But presumably there's a... Yeah, right. There's this one too. But that's okay. And then simp, I think yeah, okay. So instead of simp, I could do apply, yeah, add, and then that's also good because then we don't rely on simp. Okay, more numerical proofs. That's an interesting one. It's probably going to be this. But it's not an add, that's the thing. Let's see, what does this thing say? Oh, right, I forgot about apply. We got to try out apply. Okay, from these examples, it should be clear that being able to find the library theorems you need constitutes an important part of formalization. There are a number of strategies you can use. Test. Okay, I hope it's not too loud. You can use the API documentation. You can rely on MathLib naming conventions. If you right-click on an existing theorem, and you can use apply, question mark. All right, so yeah, so I think it takes a while. Right? Like it's supposed to show up something, right? I think it's searching. Oh yeah, there we go. It just colored it in. There we go. It's running out of time. Wait, it found it. Bro, that's not helpful. I want to look at the solution. I don't even know what it's trying to get from me. Sub LE sub left. I could have figured that shit out. Refine? I've never even seen that tactic before. Or exp LE exp. Okay, let's keep going. What happens if we do... I just want to try simp. No, that's stupid. Lin Rith. Pretty steep learning curve. S less than or equal to T is definitionally equivalent to the oh yeah, ring is used a ton up there. Finally, notice that in the second line of the second calc proof, instead of writing exact yeah, that I don't really get that. Like why you don't have to say by, but you can just make a proof term. All right, let's fucking get it. Oh, we're almost done with this section. Still pretty far from finishing the first chapter, the first real chapter. Dun 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 Dun, dun. Dun, dun, dun. Okay, so a times abs of a times b is less than or equal to a squared plus b squared over 2. It's kind of interesting, actually. It's not immediately clear to me that that's true. A Okay, so if a and b are equal, then both the left-hand side and right-hand side are the same. All right, so I don't know how to prove this. Like, does it have a hint? Oh, you know what? I have that written on my thing. Okay, yeah, I was looking into that one. Freak on my geek, Mr. Meek. Okay, so all right, nice. This is probably going to be a calc one. Huh. I wonder how you do this one. A times b is less than or equal to a squared plus b squared over 2. What is this? Why do you need to do that? A is less than or equal to b over c if and only if a times c is less than b. Okay, so then here, What is fact one? Oh shit! They caught me not doing the walking through these long ass calc ones. Interesting. Very interesting. Wait, where the hell is fact one? Oh wow. Yeah, that's crazy. Oh yeah. That's true, huh? That's crazy. That is true. I didn't think about the factorization, a minus b squared, but that is definitely the right way to do it. And then this way, isn't this the same thing? I don't know why that's true though. Um, yeah, okay. All right. I mean, that's a good proof. All right, I'm going to continue. Why are there always... I guess it did have to restart the client. How is this defined? Okay, let's just read the thing. The min function on the real numbers is uniquely characterized by the following three facts. Min LE left AB. Min LE right. Notice that we have to apply min to a pair of arguments, a and b, by writing min ab rather than min a comma b. Formally, min is a function of the arrows associated to the right. So the type is interpreted as real. Querying is so trippy. Okay. All right. right, so the proof that the min operation is commutative. That's the proof, but what's that proof? A partial order is a reflexive, transitive, antisymmetric relation. Right. It's defined by that. And a preorder Okay. So this took min AB is equal to min BA, and you apply okay. So then what does this do? So after this we have two goals. Right. So then min AB is equal to min BA. Okay, so the way we do it is apply LE anti-sim. This gives two goals. To show that one is min AB is less than or equal to min BA. And two, min BA is less than or equal to min AB. Okay, so then to prove the first one, I don't know what show does. Show finds the first goal whose target unifies with T. I don't even think you need to put that in there. But whatever. Okay, apply LE min. Which gives us an LE min. LE min is H1, C is less than or equal to A. H2, C is less than or equal to B. Min. Okay, produces 2 goals. So now we need to show that just one min AB is less than or equal to A, or B. B is the first one, doesn't matter. And min AB is less than or equal to A. Oh wow, there's a lot of proofs of this. Can you do repeat in a rewrite? I would hope so. That's really cool. But for real, you're gonna make me do this? Okay. Yeah, we should probably do this. Okay, my favorite proof is probably this one. It's literally got to be the exact same thing. Is there a max com? I don't like this fun thing. This thing makes no sense to me. Library proofs are so advanced, bro. The hell is this little arrow? I don't know. This is probably called Easy, bro. Down, 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 down. Whoa. Right. Yeah, that makes sense. The first apply uses HAB, and the second one uses HBA. It is an interesting fact that min distributes over max the way multiplication distributes over addition, and vice versa. In other words, on the real numbers, we have the identity that min A of max BC is less than or equal to max of. Wait, so if we were to do A times B plus C, we'd get A times B plus A times C. Similarly, min A. That's weird. do this one? Let me read it. In the next section, we will see this does not follow from the transitivity and reflexivity of less than, and LE, of Lie. And the characterizing properties of min and max enumerated above. We need to use the fact that Lie on the real numbers is a total order, which is to say it satisfies for all x, y, either x is less than or equal to y, or y is less than or equal to x. Here the disjunction symbol or. In the first case we have min xy is equal to x, and in the second case we have min xy is equal to y. We will learn how to reason by cases later. For now, we will stick to examples that don't require the case split. Damn, I feel like I should probably do these exercises. It's probably the same thing, right? Apply LE. So then that gives us two goals. Dude, this should... I want to change that. I hate that. Facts, dude? Do I need to write R? Okay, fine. So let's apply this. I don't even know if I'll be able to apply this. Why is it possible that I won't be able to apply this? Wait, but you know what I want to do? I want this proof. Wait, we don't even need to apply this. Wait. I want to see the example for this. I'm totally lost. This is a long proof, dude. Triangle inequality? Alright, you know what? We have to write this. What does that do? Wait. A.H1.B cross? What does that even mean? Wait, what do you get after this? I don't really get this part. Okay, fine. Oops. Okay, so what is the first step? You know what? I want to do this. Let's see what's going on here. Are you able to do like? Can you do that? It's not a tactic, but wait, min le, is it le min? Oh, it's le min. Um. Add le add apply add le add. Oh wait. Is that what we do? No, we do this, right? Um. Oh wait, do we have two goals here? Apply. Yeah. Yeah. So that's it, right? Okay. Well, so if I were to explain the proof of Ox just in English, I would say there's cases. Okay. Okay. If I have min AB plus C, and I want to prove that that's less than or equal to min of A plus C and B plus C. Well, there's two cases. One case is that min AB equals A. So in that case, we have A plus C. And we know that, which implies that B is less than... Wait, what does it do in the case of a tie? Okay, well, we know that B is... Wait, I just want to do eval min 3 and 3. Or wait. It's the same, of course. And it doesn't actually matter which. So, whatever. We get the implication that, or the fact that B is less than or equal to A. So that means that we get and we know that A plus C is going to be greater than or equal to B plus C by add LE add or whatever. Is that what happens when we do this thing? Okay. This is a good proof too. I like this one. Yeah, apply LE anti-sim. Can you do that? Let's see this. Yeah, that because this is not the head of this expression is plus, not min. So it's not going to find it. So, um, Oh wow, this is way more involved than I thought. Oh, interesting. Okay, then you rewrite it to have the minus c plus c. So then the goal is now... Oh, that's... whatever. That's not even that cool, man. I didn't get this part. The LE trans, I didn't get that part. Okay, so I feel like they didn't explain what this A.B.C.B cross thing is. Like, when you, like, I get this. I get up to here. This is fine. Then we have a less than or equal to, so now we need to prove that min A plus C, B plus C, plus minus C is less than or equal to A, and then there's the second case. I don't get this thing at all. I don't know what it's doing. Oh, we applied aux though to get this. Oh, and then you fold it in. What? Wait, hold on. What about this? Dude, what is repeat? How do you even use repeat? That's stupid. Uh, oh, wait, we don't need this. We need this. Okay, so... Okay, so first I want to just do rewrite sub, or sub-self. Not sub-self, though. Add neg. What is it? Alt-enter? Not alt-enter. What is it called? How do we do it? Control space. What? Oh, but this one did do it. That bothers me, man. I don't get that at all. Alright, whatever. Apple sauce. Okay, now there's some weird thing. Have H be, wait, why? Ay, 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 ay. Ay, 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 ay. Okay. Can apply, not aux, but, add, add right. Okay, then apply. Now now that we have a min at the head on the right, we can say apply LE min, right? But that's not what they did. They did something sneaky. This is the part that I do not understand, is where you apply LE trans. I don't know. Okay, before this we had, the goal was min A plus C, B plus C, plus minus C is less than or equal to min AB. Okay, and then what they do is apply LE trans. And LE trans is, you have H1 of A is less than B or equal to B. H2 is B is less than or equal to C. And H3 is A is less than or equal to C. That's got to be it, right? Yeah. So then when you apply this, what you're doing is you're introducing so in this case, A is defined as min A plus C, B plus C, plus minus C. And B is defined as min AB. So we're going to get H1, A is less than or equal to B, and H2, B is less than or equal to C. What is C in this case? I don't even know what C is. So wait, no. C is equal to min AB. And so this is, so B is like this weird hole. And then this one, right, C is min AB. Yeah, okay. It takes a little bit, but that makes sense. And then we have this random new thing, B. Can I tell it how to name it? Why does ox even apply here? I don't even... What does ox do? Ox solves that goal. What the heck? Okay, so B becomes question mark A dot BC dot B cross. And then once you have that, you apply aux. So the two goals are min A plus C, B plus C, plus minus C is less than or equal to question mark A dot BC dot B cross. I don't know. And then the second goal is A dot BC dot B cross is less than or equal to min AB. So then aux LE trans would still work if we didn't call this, but aux would fail, right? I guess aux didn't fail. Why did we need to do that? This proof is difficult, man. Why does aux do this? I don't get it. How does it? What is the doctrine for apply? The current goal against the conclusion of E's type. Okay, all right. Let's move on. This one is weird. I don't get the I don't get what's happening here. I just don't see it. What is it called? I don't think it's comparable, but Okay, it's time to continue. Let's see. Dude, I want to finish this chapter at least. Damn, bro. The proof stepped up their game. Shit, these ones were difficult. Max was easy, but Minnesota was crazy. I didn't even do Minnesota. I just stopped. Ox was fine. But then this one, whatever it's called, is super hot fire. Damn. Okay, let's continue. We're here. Abs add abs add abs. Did abs. Boy. Use it to prove a variant. Okay, first off, what is the proof for abs add? The hell is this? Simpa. A dog comment. Bro, I don't know this syntax. Because this just constructs a proof term, which, the annoying thing is that it doesn't tell me anything then. Like, I don't have any understanding of what this does. Nah, this crazy. Um, Wait. Okay. So the first thing is probably rewrite. What is it called? Sub eq ad. I'm doing a tactic proof, bruh. As long as I can get the answer. Oh wait, hold on. Wait. Um. Okay. How do I prove this is normally? A minus B is less than or equal to abs of A minus B. How do you explain this? How do you explain this proof just with words? Right. Okay. Bro, I am lost. A dumbass. But I don't know how to prove this. Is equal to... Yeah. It is less than sub less than sub right. Oh, that just removes the b's. And then, of course, we have to rely on that. So now we have, what did that get us? I don't really get. We're still in the calc block, but what is there? Like, what is this even? Where are we at here? Oh, wait, we had something. Add sub cancel. Huh. Okay. Okay. That sort of makes sense. Let's see if I remember how to do calc. So yeah. A minus B is equal to A minus B plus B minus B by, so I cancel. Is that right? What did they do? Oh, yeah. Okay, then you say blank is less than or equal to A divides B times C. Is this the same thing? I don't get this theorem. How is that different from this? Oh, I get it. Okay. Yeah, this proof makes sense. I'm in the solutions. X divides W. Is it the whole term? It's got to be. So that means we have x divides y times x times z plus x squared plus w squared. If that's the case, can't I do this? I'm not going to use it. I just want to. Can't I do it again? What? Why the hell is that not working? Forgot. What's the syntax for a theorem? Bro, I don't get it. Bro, what? Oh, wait. I don't get it. But I feel like I'm probably not allowed to use these. Oh, we are allowed to use div add. But you know what? I don't understand why. Okay, so then the first one. So how did this work exactly again? It was that div mul of div left. So wait, so we're doing the right, so it should be x times z? Okay, cool. Then divide mul right. Why is it divide mul right? The divisible part is on the left. That's so confusing. What? Dude, what is going wrong? There's some weird indentation thing. This makes no sense. Alright, so he did it. So, you know what? I'm going to do this. I'm going to tab this in. Okay, I don't know what was going on with that. I really don't. Honestly, the white space, like, I feel like it's just a poor choice. Like, yeah, you have the goal state, the tactic state, or whatever available to you, but white spacing just makes this so whatever. I'm sure it looks ugly the other way around too, but this is just totally crazy. I don't know. I don't know. Bro, let me cheat. Let me cheat on this. Apply GCD commutative. Um,
we noticed that our machine learning workloads, they spend roughly 30% of the time reading data before even processing the data. So what if we can make the reader roughly 2x faster? We can shrink this by 15%, which is savings. And you can see.
all right, cool. We're back. Whoa, some fancy shit. I don't know how to prove this. Let me go to the solutions. Oh yeah, I should have known. All right, maybe we can figure it out from here. So we're gonna do apply nat.gcd anti-symmetric. Hello, hello. Bro, what? Oh, oh, oh. These aren't real. Oh, interesting. Right, okay. Do we have that up there? you having it there?
So you can pick some or all, whatever you want.
Oh, what's up, bro? What's going on, man? All right. Let's see. What are the hardest ones we did today? Yeah, this one was tough. This one just didn't even make sense. Yeah, oh yeah, I like this one. That's a good one. So there's the B is less than C, C is less than or equal to D, B is less than C, H2, C is less than or equal to D, and H3, D is less than E, and the proof is A is less than E. Dun, 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 dun. Wait, what is that? One. What is that? Yeah, that's what I thought but I didn't want to clown on it. Bro, you just baited me, dude. Oh shit. That's so funny. Dude, what you been up to? Yeah, no, I believe that you actually went there, but it's hilarious. Okay, what else was good? Oh yeah, I liked these. I liked these ones. A is less than or equal to B. So therefore, log of 1 plus XA less than or equal to log of 1 plus x b. That's great. Cool. I wonder if Poland has good coverage on free-to-P. I wonder if there's a lot of OpenStreetMap users in Poland. Nice. Poland has 3D. That's sweet. Damn, dude, this place looks beautiful. Poland would be such a cool place to visit. I feel like people don't tour. There's like, I feel like when people talk about Europe tourism, Poland is rarely mentioned. I feel like people only go to Italy, France, Spain, and Germany, and the UK. Like, east of Berlin, like people I feel like don't even go. Yeah, seems like it. Lodz. My man in Lodz. Yeah, it is on the outskirts. Huh. And why do we use... Wait, we don't even use H0. Oh, yeah, we do. Log less than log. It requires a proof of the fact... Dude, Ole, I feel like you'd like this programming language. It's called Lean. And it's for proving math. It's pretty sweet. Krakow Center. Krakow Center, Poland. Where is this in relation to Warsaw? Is Krakow near Warsaw? Why isn't it populating my... Oh no, it's not even... Krakow is not near Warsaw. Dude, I love this. I love when the roofs are copper. It's just so pretty. Oh, Krakow is the second biggest city. But you're in Warsaw, right? Da, 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 da. Oh, yeah. What's the population of Poland? Oh, wow. Actually, compared to... I was not expecting that. It's like... Huh. Wait, actually... Actually, wait. Pop density of Poland per square mile. Let's see if this works. First, Germany, pop density. Does it plot them both over each other? Damn, that did not work. Compared with. I mean, that's kind of cool operation in itself, but that's not what I wanted at all. Ugh. Let's see. What happens if I do this? Oh, nice. It is a time series. That's fucking sweet. Line plot list line. Is there a time series plot list line plot? What if I just do list line plot of P1? Is that gonna work? Yeah, Germany is 2 times higher. Okay, so here, but I want to do this, and I think I can give this a list. But I want to do P2 is equal to Germany population density. It didn't. P2 Germany population density over time. It's crazy that I got the over time part. This plus all thing, that is so cool. Huh. How do I, let's see. Right, I want to copy this. I'm going to do. Oh, it's going to be ridiculous. That's not what I wanted. I want this. It should be just entity country Poland. I wonder if America will work. Wait, I could just do this. Am I dumb? I want to copy that thing. Dude, this programming language is so cool. It's so easy to do anything. That is fucking awesome. Wait, what is this? What are the units on this thing? This can't be million. Oh yeah, this is the density. That's the interesting part. Wait, so can I do legend equals? I want the legend. What happens if I just copy and paste this? It's gonna be a huge mess. And you make this code plot with a legend of the countries. Yeah, it's per square mile. Well, I don't know what units it's using. Could be square kilometers. Yeah, probably is square kilometers. Let's see. Can I, if I just Google population density Poland, it doesn't give me a plot. That's the problem. Oh, dude, this code sucks. That's the biggest problem about ChatGPT is it just doesn't know how to write good code with Mathematica. Plot legends. This is probably going to be a mess. What if I just type in this? Plot Poland, Germany, population density over time. If it gets that, I'll be really shocked. See, it made a list, but it didn't plot it. I wish they just had a high-level plot command that did the most reasonable thing. Oh, cool. You can actually see the samples. Oh, yeah, Claude. I haven't tried Claude Opus yet. Do I need to? I think I need to pay for it, right? I should try it. I heard that a bunch of people got like banned off of Claude. For some reason, this thing is being total dick to me. Sonnet. Code to wait, what's going on? Oh, code to plot population density in of Poland, Germany with labels in Mathematica. Oh, I like this little low frame rate animation. I like that. Oh, shit. Hey, that's not bad. Let me give the same one to a chat. Fresh prompt. I don't think this is right. I think this is like way more. I think this is not going to work at all, but we're going to find out. It made up a thing. Made up a whole bunch of stuff. What was the full form of that entity? Like, what is that plus all thing? Oh, if you hover over it, date goes to all. So subscribe to Pro and get Opus. All right, let's just see if this works. I feel like just not enough people use. Could be so sick. See, bar chart? That's not even what I want, bruh. Dark blue is not a known entity class. Alright, it can't do it. So I'd have to actually read the docs. Alright, I'm not gonna fucking bother. The point is that it seems like Germany's population density has increased faster, but now it seems like the rate of change is about the same. Pretty interesting. I want to see. That's the thing is, if GPT was like really good at writing code for Wolfram language, I could then be like, all right, now I just want to take every country, plot them all together, find the one whose rate of change is the highest, and see if that I don't know. You could just do so much. You could just do so much better. Wow, the population density of America is low as hell, though. It's kind of interesting. Yeah. I mean, it's all agricultural. Soviet occupation in Poland. Oh, well. Okay, yeah, so what was here? We had, and then log less than log, we need a proof that right, so once we apply this, Then we have a new goal just to prove that one. Yeah, okay. This is a good proof. I like this one. What else did we do? Improving identities. Did we finish all this one? I spent a long ass time on molten rev. This was a good one. Okay. Dude, yeah, you should check out this language. It's crazy. Honestly, it's kind of nasty because there's a ton of keywords. Like, there's all these tactics to know. But it's pretty cool. Dude, how's the scraping thing in Rust going? Some crates to update to Hyper 1 before publishing. Nice. Dude, I want to scrape some stuff once it's published. I want to download a whole bunch of cool shit. Is it fast? I bet it's fast. When did Hyper 1 come out? Oh, a while ago. Yeah, but it takes so long for the ecosystem to update. I still get Dependabot things for like an old ass library to upgrade to Tokyo 1.0. Fantaccini is Fantaccini like a HTML parser or something? I forget what it was. Dude, did you see that someone added Jupyter Notebook? I tagged you on my Discord server. That someone added Jupyter Notebook support for that language, Cast 3. I never even looked through the PR. I still need to look through the PR. But this guy in The thing is, I was thinking like it's kind of a mess. Like, like he edits 40 files. Like what I would rather do is I would rather have a new repo with all the Jupyter stuff and keep the library as thin as possible. But it's so cool that he did this. Like this must have taken him forever, man. I don't know how long, but so cool. This is fucking awesome. Oh man. All right. Mo right inv was also tough. All right. Oh yeah, we're on this. Okay. Wait, is that even true? Okay, we have, let's say m equals 12, n equals 6. Then GCD of, can I do this? Okay. So then the GCD of, wait, but what happens if it's, is it commutative? I guess that's what we're trying to prove. Yeah, of course it's commutative, but the proof is not obvious. So, wow, that's crazy. Okay. So then, we're going to get 6 divides. It's 6 both ways. The greatest common divisor. I don't even know. Let's just read the proof. What is repeat prime? Repeat prime tack runs tack on all of the goals to produce a new list of goals. Then runs tack again on all those goals. Oh, so it's like a map. It's like a map repeat or something. What is this? divide GCD. If K divides M and K divides N, then K divides the GCD of M and N. Interesting. So if K divides 6, K divides 12, so what about if we did like 3 and 5? K divides 3, K divides 5. GCD of 3 and 5 is 1. So K is 1. Okay, that's a very cool theorem. Ooh, induction. We haven't even gotten to induction. Is it cold in Poland? It's pretty nice. Okay. So then we get two things to prove. We need to prove that that divides N and it divides M. Okay. Huh. Yeah. It's hot here too. All right. Da 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 da. Okay. I'll just finish this one and this will be my last proof for the day. Oh, I'm dumb as hell. Duh. GCD. Wait, what is it called? Yeah. Um. NMMN. Okay. So let me just apply the exact same thing over again. That's pretty neat. What? Oh, yeah, okay, I get it. Alright, that's a cool proof. The commutivity of GCD is given by that would be crazy if it wasn't commutative. Alright, well, let me just read the first part of the next section, I guess. In section 2.2, we saw that many common identities governing the real numbers hold in more general classes of algebraic structures, such as commutative rings. We can use any axioms we want to describe an algebraic structure, not just equations. For example, a partial order consists of a set with a binary relation that's reflexive, transitive, and antisymmetric. All right, I'm gonna end it. I'm totally lost. I gotta do this section tomorrow. I don't know how people do this so quickly. This thing is taking me fucking forever. Peace.